Alright everybody, welcome back. So in this video we're going to build a simple content-based book recommender system or recommendation engine. As you all know, recommendation engines are one of the most important data analytics tool followed by firms to create personalized content or personalized experience for the customers or clients. Alright, and one great example for that is Netflix uses our watch history as data to create or recommend product or recommend movies or shows which we might like. So again, when it comes to recommendation engines, there are three types. One is a content base, which is what we are going to build today. Content base actually understand the characteristics within the products and tries to find out similar products with similar characteristics and suggest those products as recommendations here, in this case books. The second one is collaborative based, which understand user behaviors. For that we need to have user data, so it could understand user behavior, find similar users with similar behavior and recommend products to each other. The third one is called hybrid recommendation engines, which is like a blend of both collaborative and content-based recommendation engine. All right. So, but in order to start from the basic, we are going to build a simple content-based book recommender system. But in the future, I'm planning to make collaborative filtering recommender engine as well if I get the data, and in the future hybrid as well. Right. So let's get started. So as you could see, I've already imported the basic packages we need for this analysis. Pandas and NumPy, we would pretty much use that in all our projects, basic packages. But I want you to turn your focus to these two packages, TF-IDF vectorizer and nearest neighbor, both from scikit-learn. Scikit-learn is one of the famous machine learning algorithm provider for Python. All right. So nearest neighbor is the machine learning algorithm itself, which will try to understand the characteristics which we are feeding in, and try to find the similar books with the similar characteristics and recommend the product book itself. So this is the major algorithm which will do the task, all right, of recommending the books for us. But in order for this to work properly, we need to give inputs to the machine learning algorithm in the form of numerical features, because nearest neighbors cannot take text as data. All right, so that is where TF-IDF vectorizer comes in. So TF-IDF vectorizer itself is two terms. TF stands for term frequency and IDF stands for inverse document frequency. They have a formula within themselves which will go through the entire text corpus. In this case, the description is what I'm trying to use as a characteristics. All right, and it will convert or rank the words into various numerical feature matrix based on the occurrences, based on the visibility and all those stuff. So once it converts a whole text data into a numerical feature matrix or numerical vectors, we can then feed that output from TF-IDF vectors, which is numericals, into nearest neighbor as input, so that it can understand and it can recommend books. So the characteristics or the content which I'm going to use as the data point to create this recommendation is the book's description. So let me show you the data I have. As you can see, this is the data I have. So as you can see, we have 52,000 rows of books data in this, and we have the title, we have the series, we have the author. The most interesting data we have is the description, which gives an idea about what the book is all about. So this is the description is the one description, the data point which I'm going to use in order to create or find out the similar books based on the input book which we give. All right, but there are several other things as well with which you can create different parameters or blend multiple data points to create more efficient model. And I'm gonna just input the data I just showed you. So, and I just want to also tell you that I'm writing this whole script on VS Code editor, and I'm planning to write this whole script first, and if when we run it, if we face any issues, or if we see any issues before we're running it, we'll rectify it. All right, so you can run this in Jupyter Notebook as well if you want. So now once the data set is imported, as you could see in the data, for example, let's go back. As you could see, the description doesn't have a uniform format. Some of them are in uppercase and some of them are lowercase, and there are a lot of unnecessary characters in it which might interfere the performance of the model. So I have to do a simple little pre-processing there. I'm gonna create a function called preprocess and text. I'm asking it to return a string of text. All right. So what I've done here is that I've created a function to pre-process the text we have. So I'm asking it to convert it to lowercase, all the description column in the total description column into lowercase. Then I'm removing some unnecessary characters. I just copy pasted the unnecessary character factors parameters here because I just don't want to waste time in that. Now what I'm asking you to do is that I'm just going to create a new column. Let's go processed, and I'm gonna apply the function here. So what this actually does is that this will create a new column with this function applied, which means we'll have the description column as usual, but at the end of the data set we'll have a new column called processed with all lowercase description and with all unnecessary characters removed. Now when that is done, we can start creating the numerical feature matrix. So this is where we bring the vectorizer. So I'm just creating something called vectorizer, dfid vectorizer. Okay, then let's create the matrix. Matrix. Bring the vectorizer, then fit transform the process column. Right, so just for understanding, I'm just gonna add a note here, creating a new column process with the function applied on the description column. Sweet. So that is that. Now if we go back here, we have now brought in the dfid vectorizer package into this, and we have now converted the process column into a dfid matrix. All right, so now is where we set up the nearest neighbor algorithm. All right, so for example, so I created something called near underscore neighbor. This is where you enter the number of recommendations you want. For example, for an input book, you give it, if you need 5 recommendations, you should give 6 here. The reason I'm giving 6 here is that the recommendation function will also return the input book as a recommendation as well, because it is also in the database. All right, in fact it will be on the top because that will closely relate to the description of the input book. But when we write the final function, we'll create a function or create a factor which will actually remove the top recommendation, which actually will be the input book itself, to show only the 5 recommendations. All right, so if you want 5, you first give 6. If you want 10, you give 11, so forth and so on. Right, then we create something called model nearest neighbor. I'm gonna use cosine as a metric for the model to find the similarities. Now it's all about fitting the model into the creating this. That is all. Now we have to create a map. Oh, okay, let me see. Okay, now we are gonna set up the YAML algorithm, which is nearest neighbor. So what I'm gonna do is that I'm gonna create something called n underscore neighbors. So this is where you enter the number of recommendations you want. For example, let's say if you want 5 for an input book, you give, if you want 5 similar recommendations, you should give 6 here. The reason is that it's gonna give the input book itself as a recommendation, because that particular book is also in the database. All right, since we are doing descriptions here. All right, so but in the later stage of the programming, we'll create a function or parameter which will remove the first recommendation itself, which will definitely be the input book, because that will be the closest to the closest in similarity to the input book itself. So it will actually give you only 5 recommendations. But here, in order to kickstart the model, what you have to give is that if you want 5 recommendations, you give 6. If you want 10 recommendation, you change it to 11. All right. Now we'll create something called model. You bring in nearest neighbor. Then I'm gonna use cosine as the metric to find the similarities between these two. Fit dfid matrix. That is it. Now we have to create a mapping with from book titles to the index. All right, so that's what we're gonna do. I'm gonna create something called title.index, and I'm gonna just index, index is equal to df title dot up by lambda x. Right, so that is that. Now creating the recommendation function. All right, so this is where you create the recommendation function. All right, so I want the title, I want the model to be model, I want the data frame, I want the title index. What else? Yeah, that should be it then. Then this is where we create something called idx. And what we're gonna do is that, so sometimes what happens is that by default this function could be case sensitive. So if you change the cases and the what it's actually in the database, it won't give you the recommendation. So I'm just asking you to take all lower cases. So even if it is uppercase, if you just give lowercase, it should return the values. I mean, return the recommendations. Is equal to model.kNeighbors. Gonna just df traders matrix and add idx to the speed. Indices. This is where you will ask the function to not show the first recommendation, which will in fact be the input book itself to be input book itself to be the recommendation. All right, to be a first recommendation. So I'm just canceling that out. All right, now it's all about return books. Title dot iloc the indices. Let's go to list. Right, so that is for the main job. Now I'm just gonna create a function. Let me just move this to the top. Okay, I'm just gonna create a function called main. So here is where we'll just create other interface kind of thing. So I'm just gonna create. So what I want to do is that okay, just creating something called book title equal to input. So once you run the function or the program in the Python in the terminal, so this is what is going to show up. First enter the book title. All right, so but there seems to be some issue. The issue is speed. And what I'm also planning to add is if book title dot lower equal to, let's say, int. All right, So once you run this program in the terminal, it's going to keep recommending you books based on the inputs you give. But if you want to end the program, what you can type is that you can type end in the end of the book title thing, so it'll automatically end. So I'm going to just add this here as well. Type into in the program. Alright, until you click end, it's gonna type end and press enter, it's gonna keep running the program. So when it does that, break if book title not in title. If the book title what you're searching for is not in the database, is what you gotta return. What I'm asking you to do is that I'm gonna ask you to print sorry, book not found in the database. Try another. Sweet. That is that. But I don't want this to break in case if you enter a book which is not in the database. So that is a function. Now I'm going to create something called rec, let's say bringing in the recommendation function and running it through the book title. Alright, so this is what happens when there is actually a recommendation. Alright, so it's gonna first show up something. What can we type? The following are the best recommendations for I'm just gonna close again. Then I just need to format the book title. Okay, so I'm just gonna move it on top so I can see. There's that. Then the next thing is to print rec and print alright, that is it. Now if I just if name to name, so that is all the scripts we have here. There is some issue here. The best thing about these editors is that they'll show you the errors straightforwardly, so we can actually change it. So just to reiterate what we did here is that imported the package, imported the data, did some pre-cleaning, created a new column with the pre-cleaned with the clean description here. Then we brought in the vectorizer to convert the whole cleaned processed column to TF-IDF matrix or numerical vectors. Then we wanted 5 recommendations for each input of book, fitted the model here, then created a mapping between the book title and to the index, and created a final function to a recommendation function, then parameters on what and how the interface will look, right? So let's copy all this, save this. Now what I'm gonna do is I'm gonna go to terminal. So always make sure you're in the right directory. So by right directory, what I mean is that you should run this terminal from the directory or the folder where the Python script is. If you are running it from the code editor itself, you will be in the right directory by default. If you are running it through the terminal going through Windows search, then you have to change the directory. Then you have to write the following script. You should write Python, then the script's name. So this could take some time to run based on the machine you have. If you have a bit of a good running machine with good performance capabilities, then it will be super fast. But I have a basic machine today, so it might take some time. All right, so now the program ran successfully and it's asking us to enter the title, the book title. So let's give some random book title. Let me think. Oh, let's do Inferno. As you could see, these are the recommendations for the book title. Inferno, it has Dante Club, Broken Heart, Tied to a Boss, Eastern Bone, so forth. So since we asked for 5 recommendations, it gives us 5 recommendations. So we basically programmed it. So let me try some other topic. Let's Right, so I tried the Great Gatsby, and these are the recommendations. So there are always ways to improve this model. So you can use different data points instead of description, or you can blend or add description with some other data point like description and genre, and create a try and check how the efficiency of the model is. You can keep improving it. That's the best thing about machine learning and deep learning. You can always there is always room for improvement, and most importantly, the result will obviously return on the rely on the data you have. So what I will do is that I'll also demonstrate what will happen. I'll just type a random topic, random title, which wouldn't be in the database because it's gonna be in a random word, to show you what will happen if we run something which is not in the database. I'm just typing kill. It says sorry, book not found in database. Try another book, just like we programmed it. If you want to end this program, type end. That's it. That's the end. So it goes back to the directory again. So that is it. So that is all for the video. So I'm just planning to work on this and elaborate this more, probably to a collaborative base if I get the user data, the corresponding user data, and so forth and so on. I'll see you in the next. And I'll also add the code I'll add this code to my GitHub repository, and I'll paste the GitHub link in the description, so you can check this code out. You can use this code, manipulate it, try different algorithms, or try to fine-tune different data points and all those. You can do whatever stuff you want with that. And I'll also add a link to this data set in case if you want to try this out. All right, I'll see you in the next.